starting the recorder now. And let me see, do I have the clock? Yep, still have the clock up. Let me make sure it's always on top. So this way the entire recording is going to have the clock up here so that you can reference, the time a little bit more easily. All right. Well, I hope you guys, you had a good break and, have enough time to recover from your break, because I know sometimes, how that goes. So what we'll do today is we are resuming our discussion with, in terms of the binary search algorithm. And, on the screen, I have the algorithm kind of totally magnified because I want to kind of show you guys how to analyze the structure of the code. Okay. In other words, we look at this code and then we want to figure out, okay, yeah, which part is, belonging to which part in terms of the structure of the code. All right, so we'll go ahead and try to apply what we have learned in BNF. Okay, hopefully you still remember what BNF stands for. Okay, how many people still remember BNF? Okay, very good. Okay. hmm So we're gonna look at this code from the perspective of the compiler. Okay, and I'm gonna highlight, certain parts of it. So I got, my pen ready here. All right, so we'll start with line 1. Okay. When the compiler looks at line 1, it first sees the letter B, okay, and it asks, what kind of a statement is this? Okay, in this class, how many statements have we introduced? There are only like 5 statements. Once the first type of statement starts with a D, it's a do statement, but that's not do. Okay, it doesn't spell correctly. Okay, the second one is a while loop, okay? And that's not a while loop because while loop starts with WHILE, okay? That's not what it is. And the third one is if, okay? And that's not if either. It is also not a brace, not an open brace, which is the beginning of a block statement. So the compiler comes to the conclusion that this is most likely an assignment statement. Now, there are other kinds of statements too that we have not talked about, but of the 5 statement types that we have talked about, the only option left is an assignment statement. So the compiler goes like, okay, I should be seeing the left-hand side first. The left-hand side should be the name of a variable up to this point of this class. And so it will understand that, oh, okay, so that means that B is the name of a variable that is to be updated on the left-hand side. Then it sees the equal symbol. The equal symbol is more like a separator. It separates the left-hand side from the right-hand side, which means now we are expecting the right-hand side or the expression that is giving us the value to update the left-hand side. So the other side, okay, let me put on my fancy, glove here because otherwise my palm will touch the screen and it will start to move things around on the screen unexpectedly. So now it sees the right-hand side, which is an expression. What is the value of that expression on the right-hand side of line 1? 0, exactly. Okay, so that means we are not we are updating variable b to a value of 0. Okay, and then we have a semicolon. The semicolon is actually needed in order to make the conclusion that we are now done with the assignment statement. So that means from the perspective of the top level code, this is one statement. Are we good so far? So I'm not going to explain in such detail of the second line. So now we have another statement from the top level perspective. And now the compiler sees the word do, okay, this word do here. So now it recognizes that, oh, this is a do statement. So the do statement has 3 parts. Okay, the first part is really just the word do itself, which tells the compiler what to expect next. So the next item of a do loop is to specify, okay, what am I supposed to do potentially repetitively? So that is from line 3, the open brace of line 3, all the way to the close brace of line 10. That's the entire second part of the do loop. The third part of a do loop is while and then the condition because it specifies, oh, under what condition do we have to go back and redo the body of the loop. So let me highlight those three parts of a do loop. This part here is not really particularly useful because it is just a marker. It's nothing more than just a way for us to tell the compiler, oh, expect a do loop at this point, as opposed to an assignment statement or a conditional statement or anything like that. Is that okay? The second part is really important because it really specifies what do we do repetitively, potentially, and it consists of everything in this entire block here. So I'm just graphically showing you the entire second part of the do loop. The third part of the do loop is the condition, is the word while, which marks the end of the body of the do loop, and also the condition that is in parentheses to specify under what condition do we have to go back and redo everything else. So this is the third part of the do loop. And I just need to get to the end here, like so. All right, so do we have any questions about identifying the three parts of the do loop? No, no questions. All right. So those are just three parts, but it really is one single statement. In other words, the third statement of the entire algorithm from the top level perspective is this entire block here. This is the entire third statement of the entire program. Is that okay? So I want to redo this, because we talked about this algorithm already right before the break, but I want to re-talk about this a little bit, but this time I want to analyze the structure of the code, okay? So that we understand, from the perspective of syntax and also from the perspective of the compiler, what does it see in this code? How does it analyze this code? And why do you think that is important? Yeah. Mm-hmm. 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 Yep. And also, when you need to construct your own code, you also need to understand how to put all the pieces together, right? And understanding the syntax is the really important part of putting your own program together. Now, in this class, the way that I usually teach this class is I don't really, have you guys to kind of make your own code a whole lot because I want you to get familiarized with reading the code itself first. Because until you can read the code that I have provided and be able to kind of take it apart and understand how the whole thing is put together, you may not have the necessary, understanding to put your own code together yet. Hmm. Yep, it's understanding the mechanics, right? Exactly. So within the do loop, okay, we have a bunch of stuff here. So we'll also take a look from the perspective of the do loop itself, what is inside the block statement. So everything from this open brace to this this end brace here, that is one single block statement. Okay, what is the purpose of the block statement? Why do we need block statements in C and C++ and most other programming languages? Say again? It is for us to pack multiple statements within one single thing. Remember, a- yes. So a block statement is like a zip file, okay? It is considered as one single file from the outside perspective, but once you double click on the zip file, you can now expand it to a bunch of files or none, okay? Sometimes you have no file inside the zip file, which is okay. It's empty. Does it make sense? Okay, so inside this particular zip file, starting with the open brace on line 3 and the close brace on line 10, we have a bunch of files. Okay, we have a bunch of statements. So I'm not going to go through the very detailed analysis here. This is one statement. This is an assignment statement. And then we have only a second statement here. From that level of perspective, this is our second statement. The second statement within the do while block is a conditional statement. Because when the compiler gets to the word if, it will understand, okay, let me see. We have five possible statements. We have do loops. No, that's not a do. We have a while loop. It's not while. We have a block statement, which is open curly brace. No, that's not an open curly brace. And then we have an assignment statement. But we don't want to deal with assignment statements yet because we look at the word if and we go like, oh, we recognize that terminal. Okay, do you guys still remember what a terminal is as opposed to what the token is? Say again? No, a token is a placeholder. A terminal is you have to type it in verbatim. Okay, so if is a terminal. Okay, this is exactly what you need to type if you want to specify a conditional statement. So this if tells the compiler, oh, we have a conditional statement here. So how many conditional statements do we have? Well, that's a tricky question, okay? Because depending on how I want you to count, we can look from line 4. Oops, let me see. I can't see it, the lining here. It's easier for me to look at it here. All right, so if we look from line 5, sorry, from line 5 all the way to line 9, at the top level, I can say there's only one conditional statement. But if I want to also count nesting, then I have two conditional statements. So let's take a look from the perspective of the structure. What the components are for the top level of the conditional statement. So the top level of the conditional statement is we see the word if, which is just a terminal. We see the next component, which is the condition. Okay, this is the condition of the top level conditional statement. This is the then statement. Okay, this is the entire thing that we need to do if and only if the condition is true. And then we have the word else, which is more like just a separator, separating the then statement from the else statement. The entire else statement is here. This is the entire else statement, which by itself is also a conditional statement. Is that okay? So when the compiler compiles, it will say, okay, this is a conditional statement. I'm expecting a condition after that in parentheses. Okay, that's cool. This is a condition in parentheses. Fine. After this, I'm expecting a then statement, which starts with b equals to, oh, that's a assignment statement, which is one kind of statement. Fine. Okay, this is good. This is the entire um, then statement. Then we optionally may see the word else. The terminal else is optional. But in this case, we do see it. So the else on line 7 is associated with the conditional statement that started on line 5. Is that okay? But after the else, we have to have an else statement. So now it goes like, okay, what is after the else? I'm expecting a single statement here. After the else, the compiler sees the word if, which means we now also, we are expecting all the other structures, the other parts of a conditional statement. So that means, the compiler will now expect to see the condition of the conditional statement, which is, the in parentheses. That's all good. After that, it is also expecting to see a then statement, which is our line 9. Okay. And now it's saying, okay, the conditional statement that started on line 8 potentially can have its own else. Except in this case, the next token that it sees is, no, not token, the next terminal that it sees is close brace, which is not an else. Which means the compiler at this point, okay, let me use my mouse pointer here. So at this point of the parsing, which means we are processing the input text here, at this point the compiler comes to a few conclusions, not just one. It comes to the conclusion that the nested conditional statement on line 8 has ended because it is not finding the optional else to that particular state, to that conditional statement. So that means we are ending the conditional statement that started on line 8 when we see the end the close brace, right? But that also concludes the then statement, excuse me, the else statement of the conditional statement that started on line 5. So it comes to both conclusions at the same time when it sees the close brace, where the mouse pointer is pointing to. Is that okay? So a lot of this is I know it sounds really mechanical, boring, and just a little bit going like, oh, this is really dry. But it's really, really important because sometimes you can write programs that are syntactically correct, but it does not represent the logic that you want to express. Those are the worst kind of problems. Because if the program itself is syntactically incorrect, it's okay. The compiler will catch it. It will complain. It will say, this program does not compile on this line. Something is not right. But if it is syntactically correct, but logically it is not structured the way that you think it should be structured, then the compiler is not going to complain. Okay, the compiler will simply say, okay, this is syntactically or grammatically correct, and it will interpret the code in its own way, which may not be what you intend. And that's worse than having the program to be syntactically or grammatically incorrect, because in that case, the compiler will at least complain. Yeah, go ahead. Okay. hmm So if I were to look at the structure of this code, I know that at this point it looks it's going to look really difficult because now this conditional statement. Okay, let me see. Why is it? There we go. So for this particular conditional statement, this is the condition right here. And this is the then statement corresponding to that if here. And because of the lack of an else terminal, it does not have an else branch. Are we still doing okay so far with this? Okay. Hmm? The conditional statement starting on line 8 has an mandatory or required then statement. But the optional else statement is missing entirely because it is missing the terminal else entirely. So from the compiler's perspective, if it cannot see the else word because it sees the and brace instead, then it concludes that, oh, okay, the conditional statement starting on line 8 is now finished. It does not have an else branch. hmm So if the condition of line 8 is true, it will proceed to do whatever is on line 9. If the condition of line 8 is false, then it has nothing to do because there's no else. That is correct. Yep. So after we analyze the structure of the code like this, okay, depending on how comfortable you are, with reading the code and understanding what it's supposed to do, I do encourage people, at least at this point of the class, to translate this into a flowchart. Okay, um, but you still need to understand structurally how the text representation of the code is structured before you can draw the correct flowchart for this particular program. Does anyone want me to kind of draw the flowchart of this program? Okay, yes, okay. So I'm not sure exactly how to do this. I think I know how to do this. Okay, so I'm gonna pinch this because that leaves me enough space to actually draw the flowchart. Is that still okay? Does everybody still see, the content? Okay, so I'm gonna draw the flowchart on the side. Okay, so we'll do it here. Okay, so this is where I'm gonna start. So b, okay, I'm gonna put a block here. B equals to 0, and also e equals to n minus 1. I'll just put both of these into one single block because this is just a normal, simple sequence of code to execute. There's nothing tricky about this. Okay, there's no decision to make. It can only move forward, okay, or down in this case. And then we have the do loop. So now we have to draw the structure of a do loop. So do you still remember the structure of a do loop? Where do we put the diamond? Yes. Mm-hmm. All right. So that is correct. Okay. So I'm not going to focus on the conditional statement that is after the do loop. Is that okay? Okay, because that's kind of after the fact of how do we interpret the values between B and E, and also, whether we have found a value. So we're going to let it not put it into the flowchart at this point. Is that okay? All right. So that gives me a little bit more flexibility in terms of how to draw the body of the do loop. So I'm just going to reserve a large block of here. Okay. This entire thing is the body of the do loop. And, oh, I think I just did something wrong. I remember, you have to use a diamond to merge also. This is really not super important. It's, because there's really no syntax to flowcharting, but I'm just going to be consistent here. Okay. So with a do loop, you do have another diamond here. So this diamond is going to be kind of more complex because this little diamond here, I'm going to have to redraw this a little bit because this diamond is representing the condition that is on line 10. Okay, and you can see line 10 is kind of rather involved. So I'm going to have to back up again, because I need more space for that diamond. So just give me a second here to redraw the whole thing. And this time I'm going to redraw the diamond first, or at least you'll specify the content. Get rid of the page number, gives him a little bit more space. So I'm going to redraw this with a diamond. So this is B is less than or equal to E, and A bracket M does not equal to V. That's our diamond. Okay. Yeah, this is a no, and this is a yes, or true. Okay. And then in between here, we have the entire block of code that is in the braces. And this yes branch or true branch goes all the way back here. All right, so I'm just going to pause here and see if there are any questions about the diagram up to this point. So are we still good? Okay, so let me just re-describe what we have seen here, what we are seeing here. This b equals to 0 is over here. This e equals to n minus 1 is over here. That is simple. That's a simple sequence, which means we have to execute it in that particular order. And then the do loop is everything, from this do all the way to the while and the condition here. That is represented by this diamond, which merges this branch back to the input or the in direction arrow into the block of code. And then when the block of code is done, when we specify this condition, that condition is here with this diamond because it's a decision point. If the answer to this question is true or yes, okay, so I'm going to put a slash true here, then we follow this branch all the way back to here and then repeat whatever action is specified here. That is one single block statement. Okay, the huge rectangle you see here is one single block statement. In the code, the block statement starts from here with this open brace and it ends with this brace over here. In the diagram, it is the entire rectangle here. It is one single statement. It is just a block statement, but it is seen as a single statement at this level of the code. Is that okay? Is this helping a little bit in terms of understanding how to look at the pseudocode and then interpret the pseudocode so that you understand the flow of the logic? Okay. All right. So what is inside the big block? The first one is not really complicated. It is just m equals to b plus e, the whole thing divided by 2. Okay, that's just your one assignment statement, which is I'm going to put a little kind of blocky thing over it. Okay, that's good. And then it's followed by one single statement, which is a conditional statement. So does anyone remember how to represent a um, conditional statement? And this one does have an else in it. It's a diamond on the top. Make a decision. One side says, what do we do when it is true? One side goes to the branch when we specify what to do when the condition is false. Okay. So the condition that we need to check here is whether A bracket M is less than V or not. Okay. So we put that here. So we have A bracket M is less than V. Put this in a diamond. Every time you have to make a decision or every time you're merging two branches into one, you use a diamond. Okay, that's just how the flow chart standard goes. Okay, so now we have one side saying what if it is true, and one side going what if it is false. I know this is a little bit asymmetric, but it's okay. It will still work. So if it is true, okay, in the flow chart, then we perform whatever is the then statement of that conditional statement, which is whatever is on line 6. So now we go here and go like, oh, okay, line 6 says b equals to m plus 1. Put a little rectangle over this, and this is my entire then branch corresponding to the conditional statement that starts on line 5. Is that okay? What about the else branch? Well, the else branch is a little bit more complicated because the else branch is basically its own conditional statement. So that means when the condition is false, then we go to another conditional statement. So with every conditional statement, you have to ask a question first. Okay, in this case, it is the condition on line 8, which is asking, is it true or false that V is less than A bracket M? So we have another diamond here. And if this is true, then we go to line 9, which says E gets M minus 1. Okay, put a little rectangle over this. But if it is false, we actually do not have anything to do. So now we have a merge here. Okay, so we have a little merge diamond here of this branch and this branch merging into here. And then we have another diamond here to merge from this branch to and with this branch before the entire thing exits. So that is representing the flow chart of the code. So are we doing okay so far in terms of corresponding between the pseudocode and also the flowchart portion? Yes. So line 7 is just the word else. Nope, it is not. Because else is expecting, so if you go back to the BNF, the terminal else can only followed by an entire statement. So it cannot be followed by a condition. It can only be followed by an entire statement. So in order to do what we need to do, which is saying, okay, we only want to perform whatever line 9 has specified, depending on the condition of line 8. So that means we still need a conditional statement to do it. So that's a good question. Okay, I like the question. But when we go back to the BNF, then we understand, oh, we cannot do it because even though syntactically it seems to make sense, to put a condition immediately after the else, but because we can only have a statement after else, we cannot have just a condition after that. Now, but your question is very interesting because what if you just put a condition after else? Is it syntactically right or wrong? Now, based on what we have talked about so far in this class, it would be syntactically incorrect because if you just specify a condition, it is not a statement. But any condition is also quote unquote a statement if you end it with a semicolon. So you can specify in this case, something that looks syntactically correct to specify the logic that you want to express, but turns out it is actually not doing what you want it to do. So so this is a really good example of why we need to get the syntax down, because otherwise you can write some code that is actually syntactically correct, but it doesn't do what you think it should be doing. All right. So are we doing okay so far up to this point? The main purpose of this segment of the class is really to look at the code again on the left hand side and translate it structurally into the flowchart on the right hand side. Are we good so far? All right. So now the question is, this is a question that I want to ask you, but you don't have to answer the question, is can you do this conversion quickly in your head? Okay, because in order to become an effective software engineer or to be successful in the next class, you need to start to develop the skill of reading the code on the left hand side and mentally form the picture of the flowchart on the right hand side. Okay, now is it possible? The answer is yes, it is possible. Does it take time to do it? Yep, I would say it takes some time to develop that skill. And the idea is you just have to look at every piece of code that we write in this class. You have to practice this until you get it down and you go like, okay, I have a mental picture of the flowchart. The key is you need to have it in a mental picture and not have to draw it out entirely. Because if you still need to draw it out on a piece of paper entirely, you won't be quick enough to be successful in the next class. So you have to be able to do it quickly enough to and do it mentally without needing to redraw the actual picture. I redraw the picture here for illustration purposes. Are we doing okay so far with all this discussion? Because this is linking everything that we talked about back to BNF, back to conditional statement, back to loops, and so on. So it is just a chance for me to repeat some of the material that we have already gone over, but in a slightly different context. So are we good? All right. So we can always come back to this, if you want to. Okay, I'm leaving the tablet open, and we are going to go back to the new homework assignment. So you have a new homework assignment that is due in a week. So next Monday is the due date. So I want to go back to here. It is called binary search. Okay, so binary search is your new homework assignment. It is due on the last day of March before 9 a.m. So if you click on this, you will see that there's a source document. The source document is a Google Doc or the Google spreadsheet or Google Sheets. You can either download it and work on it locally using Excel. Some of you probably prefer to do it that way. Or if you want to, you can also just make a copy on Google Drive like the other homework assignments. There are 3 traces to complete. Let me just go there and show you what the document looks like first. So this is a document. The code is written here. These are the line numbers, which are basically just the row number. Okay, and it's basically the same code that we have talked about so far. The syntax is a little bit different, but it's specified basically exactly the same kind of logic that we have been talking about. There are 3 traces. So this is trace 1. Yes. Ooh, we do. We're losing so many days. I don't like it. Let's take a look. ARC academic calendar. Ah, okay. So what is the occasion? I don't. Oh, you're correct. Okay. Okay, so I'm gonna have to postpone the due date to next Wednesday then. All right, let's postpone that to next Wednesday, which is April 2nd. All right, there we go. Save. All right, thank you. Yeah, I don't like it when we have a long break and then we have another day that we are going to miss class. All right, so this is what trace one looks like. Okay, you have array A already initialized. You 1, 2, 3, 3, 5. There are 5 items. So n equals to 5 here, and then k, the value that we are looking for is 4. So you just have to complete the rest of this trace. I have already pre-make all the columns for the variables here. So the rest you just have to kind of follow through. Okay, and comments is on this side. If you want to put it on this side, that's fine too. Okay. In fact, I'm just gonna move it over. There we go. So trace two is kind of the same deal, except we're looking for 6 this time, which is also missing. So let me just kind of do this pretty easy. And then this time we're looking for the value 1, which is which can be found here. So we just kind of do this all the way over here. Okay, now we're all good. Um, are there any questions about the homework assignment? Yes. Hmm? Yes, you have to complete all 3 traces. So trace 1, trace 2, trace 3, based on the algorithm in the code tab. So go to the code tab. This is the algorithm that you're following. It is almost exactly the same as the one that we talked about earlier, but it's not exactly the same. So I would just use this as the reference. I need to explain line 4 a little bit because this time b plus e divided by 2 may be a fractional number. You might get something like 2.5, okay? So in the case it is 2.5, according to this comment here, you just truncate the fractional part. Does everybody understand what is truncating the fractional part of a value? Okay, so if you truncate 2.5, it is 2. So you're just getting rid of the fractional part or anything that is on the right-hand side of the decimal point. You turn it into an integer. Is that okay? Yeah, you just get rid of everything, on the fractional side. So we are not rounding because rounding implies that if it's zero point 0.5 or more, you round up. If it is less than zero point 0.5, you round down. Truncate means you're always rounding down. Is that okay? All right, cool. So that's the only extra part that I have to explain because I did not use an n. That is always nice to have b plus e divided by 2 having an integer. So this time you might get a fractional number. You just get rid of the fractional part. Is that okay? All right. All right. So with that said, let's go ahead and take row first, and then we are going to continue. Okay, so the row taking part is here. Let me unhide it. There we go. Today is the 24th of March, and the access code is log n, LOGN, all lowercase. So let me just write it on the whiteboard. Log n. Yep. This is a term that you will hear a lot more as you proceed to more advanced classes in computer science. All right, you guys come in just in time for row taking. So sign into your Canvas account, and we are taking row right now. So I'll give people maybe well, maybe 1 more minute, okay, and then we'll proceed. People who come in a little bit late, you can kind of try to catch up with the rest of the class. but I'll give the class another 45 seconds and then we'll move on to talk a little bit about, but how do we construct algorithms to begin with? Okay, so we're going to give ourselves a task so that we can go like, how do we construct algorithms step by step? All right, well, a minute is passed, so I'm going to continue with the discussion of, how do we construct algorithms? So this is one of those things where I will kind of like disperse, these discussions from time to time. Okay, it's not going to be like a super focused discussion, but because it really is, it depends on how you think as well. Okay, so let me switch to a different slide. Let me see, how should I do this? Well, I'm going to use Google Doc again, and I'm going to create a new Google Doc for today's class. So this way, you don't have to worry about, taking notes. Everything that is typed in this document is already captured on Google Drive. It's in the share folder that you all have access to. So you can kind of focus on, the idea of how do we construct algorithms. So we get rid of that, and then we just go like, how to write an algorithm to. All right, so we want to write an algorithm that involves arrays. Okay, so what an array really is just a bunch of numbers for us. Okay, at least up to this point of the class, it's just a bunch of numbers. So the question now is, what do you want to do with those numbers? So I can give you guys some choices here. Okay, we have already talked about the algorithm to find the largest, the maximum value. So I don't think we want to go back and revisit that. We have talked about algorithms to initialize an array, meaning that we put the same value, like a zero, into every single one of those values. So how about an algorithm to find the number of runs in an array? So I'll describe what that means. Okay, so I'll first give myself an example. Okay, so find the number of runs in an array. So I'll give you an example. So we'll go ahead and start with some values. I'm not even bothering to write down the indexes of the array elements. So let's say we have 4, 5, 2, 3, 10, 9, and then back to 8, go to 4 again, and then go to 7, and then 9. Okay. So what I mean by a run is um, a block of numbers, contiguous numbers that are in sequence. In other words, it depends in this case, if I want to be non-decreasing, okay? So let me put in parentheses here, non-decreasing. So that means, 4, 5 is a run, okay? Because 4 to 5 is non-decreasing, it's good. But then when we get to 2, it cannot be in the same run because 2 is less than 5. So 2, 3, 10 is a run. This is our second run. 9 is by itself because 8 is less than 9. So this is our third run, which only has one single item. 8 is also by itself because 8 is less than 9. And then 4, 7, 9 is one run itself because they are in the correct order. Are we doing okay so far? Okay, so I'm going to do some highlighting here just so that it's easier for us to identify the runs. So 4, 5 is one run, and we are going to go to the color portion. Okay, text color, highlight color. We'll use highlight. So this is one run. 2, 3, 10 is one run because they're in the correct order. So I would use a different, slightly different highlight. And we'll pick, I try to avoid the high saturation colors like this one maybe. Okay, and then 9 is by itself. Okay, because it is followed by 8. So now we use the same one. Okay, I'm just alternating between these two colors. 8 is also by itself, and then 4, 7, 9 is one particular run. So these three belong to the same run. So is that okay? To kind of use highlighting to kind of indicate the runs of this particular array. So we have 1, 2, 3, 4, 5. We got 5 runs. Are we good so far? Okay. So the concept of a run is going to be useful. I would say, let me count. 360, 400, 430. So in about 3 semesters, okay, assuming that you're going in this sequence, you will go back and go like, oh, okay, so this is really an important concept in an algorithm that we called merge sort. Okay, we are not going to talk about merge sort in this class, but the whole concept of a run is useful when we need to describe merge sort. Okay, so this is just a concept that we want to talk about later. All right, so now the question is, how do we do this? How do we find the number of runs in a particular array? What is the logic to do it? So what goes through your mind when you're trying to make an algorithm to do this? So before class today, I actually did not plan to talk about this example so that I can actually go through the process too. Because I don't want to come into this class having an example and all the steps already figured out in my head. Because I want to go through all those steps along with you so that we can go like, okay, how do we get started here? So the one thing that I usually start with is to say, do we need some kind of a loop as opposed to, oh, we just need a conditional statement? So what do you think? Do we need to do something repetitively in order to figure out the number of runs here? I think we do. Okay, very good. So that means we need some kind of a loop. So I'm going to start to write a program that is not a program. Okay, it is pseudocode. It is not going to compile. It is not syntactically correct. It only makes sense to people. It does not make sense to the compiler or the computer. Is that okay? And that's usually how I start when I'm writing an algorithm. I don't write it in code. I don't put it into a compiler, okay? Because I don't want to bother with the syntax at the beginning. I want to focus on the concept. Okay, so we'll say, oh, we need some kind of a loop, okay? And I typically I use loop and loop, so that I can identify what is in the loop itself. I think since we are counting something, I need a variable to do the counting. Does that make sense? So that means I need some kind of a variable to do the counting. So I'm gonna say run counter, okay, and I probably need to initialize it to 0 first, okay. Let me see. Well, I think we should initialize it to 1 because at even if the entire array is already sorted, it's one single run. So the number of runs is always at least 1. So I might as well initialize it to 1. Does it make sense? Okay. So what do we do in the loop? And also, how do we get out of the loop? So the way that I think is whenever I know that there's a loop, I think about when do we get out of the loop? Because by thinking about when do we get out of the loop, that will give you some clue of what do we need to do in the loop. So the question now is, what is the job of this loop here? We are not going to sort anything. All we need to do is to keep track of how many runs we have. So go ahead. What is the purpose of the loop itself? Because we know we're doing something repetitively. So now the question is, what are we doing repetitively? Or when do we get out of the loop? hmm In other words, what we are doing for each iteration of the loop is we are comparing one element of the array with whatever is right after that and see if we broke a run, right? Because if we are breaking a run, then we have to increment the counter by one. Does that make sense? Okay. Inside the loop. Okay, very good. Okay, I like that idea. Okay, so we need a conditional statement in the loop here. So I'm going to use indentation, to kind of indicate the nesting of the statements. So once again, this is pseudocode. It is not C code. So we need some kind of a conditional statement here, which always has to specify, a condition, and it needs an end, right? And optionally, we might have an else here. Okay, so remind me, what do we need to check here? If a run is broken, okay, then what do we need to do if a run is broken? You, an assignment statement, that is correct. So since we only have one single variable up to this point, what do we do with run counter? Add one to it. Okay, very good. All right, cool, cool. Do we have anything else to do if a run is not broken? Nope, we don't have anything else to do. Okay, fine, we'll just leave the else branch empty, okay? But if we don't do so, now the question is, how do we keep track of which element is compared to which element is compared to which element? I think we need something to keep track of, where we are in the array so that we can say, oh, we are now comparing this element versus the one right next to it. So I think we need an indexing variable to keep track of which two elements we are tracking. Does that make sense? Okay. So now we go back and go like, oh, okay, we need another variable to keep track of the index of the element that we are comparing. I'm just lazy. I just use I as an indexing variable, okay? But you can name it appropriately, like array index variable or something like that, okay? So that means after each iteration, I probably want to bump it up by one. Does that make sense? Because with each iteration, I'm comparing some element with whatever is next to it. And in the next iteration, I need to compare the next two, and then the next, 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 next. So that means I needs to be incremented by one for each iteration of this loop. Be good? Okay. All right. And so how do we specify when we should get out of the loop? So end loop when blah blah blah. Okay, so tell me what condition I might need to specify here. You don't need to use correct syntax or even to make use of the variable. You can just kind of record an idea. You can say when we run out of elements to compare. How does that sound? Okay, so we can say that. Okay, so we say when we run out of elements to compare. After we scan the entire array, we're good to go. Okay. So when you look at this code, it's like, wow, this is not even close to C syntax. It's not. But we're focusing on the idea. Yep. Hmm? Oh, the entire thing, I'm using a slightly different syntax here. So in this case, because it's just pseudocode, so everything here is the body of the loop. Yep. So because I don't when I specify loop and end loop, I don't even know whether it should be a pre-checking loop or a post-checking loop. So in this case, I'm just saying, okay, we have some kind of a loop here, and the loop concludes when we run out of elements to compare. So this is really loose logic here. Okay. And the idea is you don't need to always come up with the most concise and correct way to specify the logic. You just record your thoughts, okay, of okay, these are the things that we need. You can kind of rearrange things a little bit afterwards. Are we doing okay so far? Okay. So now we look at this and go like, we got a few loose pieces here. What do we mean by a run is broken? And how do we determine that we are out of elements to compare? So what do you think? So I'm gonna call this version one, and we'll work on version 2. Okay, so this is copy and then paste here, and I'll even put in a header here. Okay, so we'll put in a, I'm going to use header 2. This is version 0, and then we'll have version 1 here. So this is version 1, and put it in heading 2. Okay, so in version 1, we are trying to refine the logic a little bit here and see if we can replace some of these description with something that is a little bit more appropriate. So now we have to say, oh, we might need to name the array, right? In order to refer to elements of the array, we need to name the array. So the array is array A, okay? It has to come initialized already, otherwise we don't have anything to process. Okay, so given the array has a name of A, how do we determine that a run is already broken? And I is the indexing variable, right? So we are using I to keep track of which two elements we should be comparing. So how do we specify a run is broken? In other words, a particular element. Oh, okay, let me go back to. Okay, let me do this. This is a nifty trick, just to take a screenshot here so that I can display this continuously. Always on top. So this way I can scroll back down. So how do we know a run is broken? We compare 4 to 5, it's good. We compare 5 to 2, aha, broken. We have to increment the number of runs. So go ahead. That is correct. We need a condition. We need a condition so that the condition is true if and only if a run is broken. Okay, so now we can go like, okay, I think it has to do with a bracket something compared to a bracket something. So the question now is, what do I put in the square brackets and what do we replace the question mark with? Yes. Okay, very good. Okay, so we are comparing consecutive elements, which means, if one is a bracket I, the other one is going to be a bracket I plus one. Okay, so let me just pause here and see if that makes sense to you guys, right? Because we are always comparing consecutive elements. So we compare the 4 to the 5, we compare the 5 to the 2 to the 3, and so on. So that means in terms of the indexes in the array, for the elements, we're always just comparing whatever is at the index I, which I use I to kind of control the point of the comparison, and whatever is right after that. Okay, so now the question is, if I need to increase the run counter by 1, what do I need as a comparison operator here? And comparison operator is less than, greater than, less than or equal to, greater than or equal to, or not equal to. You got 6 choices here. Well, if it is less than, we are still in the same run. If it's greater than, right? So we now know that, oh, okay, if a bracket I, which means the element earlier, is greater than the element that is right next to it, then we have just broken a run, and as a result, we have to increase run counter by 1. Is that okay? All right. So we got that figured out. That looks good. This looks good. Okay, so now the question is, when do we run out of elements to compare? So with this, okay, now I have to specify the number of elements in the array is n. Okay, so that it's just consistent with how we use n as a variable name, to indicate the size of an array. It doesn't have to be n, but I'm just using the some whatever is consistent with what we have talked about so far. So now the question is, how do we know when we run out of elements to compare? I starts with a 0, and with each iteration of the loop, we increase it by 1. So that means eventually I is going to hit some number, and we go like, oh, okay, I think we are out of numbers to compare now. So the question is, so we know we involve I here, and we also know that this involves n because n specifies the number of elements in the array. The question is, what do we use as a comparison operator in order to, well, I mean, that's not just it, but we'll just work on this part for now. Yes. Now, when I equals n, then we should get out. Okay, but this specifies, oh, you're correct. Okay, we exit the loop when, okay, so when I equals n, so we just put this in for now. Okay, and note how I use double equal. Why did I use double equal instead of a single equal? Because a single equal means what? How do we use a single equal? Yes, yes, whether they are the same, right? Okay, so this is really important because I guarantee everybody in this class will get bitten by this one at least once in Cisp 360. Okay, you're gonna use the wrong comparison. Okay, you meant to compare, you should have used equal equal, and then by accident you use a single equal. I guarantee everybody in this class will be bitten by that one at least once in Cisp 360. I still get bitten by that one occasionally. Okay, so once again, one equal symbol means assignment, which means you are using whatever is on the right hand side to update the left hand side. Double equal means I just want to compare. Are they the same or not? Is the right hand side having the same value of the left hand side or the other way around? Okay. This is super important, okay, because I know what some people are thinking. It's like, but assignments are statements, they're on their own, and from the context of where this operator appears, the C compiler should be able to figure out whether I meant to compare or whether I meant to update. The answer is you can actually have assignment inside where a condition appears because assignment actually is not a statement. It is actually just an expression. It is so you're going to ask, but Tag, you kept saying your assignment is a statement. What is the deal of that? Because I want to simplify things a little bit for this class. So that's why I only mentioned that assignment is a statement. But in reality, assignment can also be just an expression. And any expression can be interpreted as a condition in C and C++. So yes, you can specify an assignment operation in a place where you're expecting to see a condition. And the compiler would actually go like, well, I assume you know what you're doing. Let's go do this. And that bug is, that kind of bug is really difficult to spot to begin with. So the program will compile. The compiler is not going to complain unless you turn on all the warnings, which I recommend you guys to do when you move on to CISP 360. The first thing you do is to figure out how to turn on every single possible warning for the compiler. Okay, let the compiler figure out, hey, you might have a problem here. Okay, because it will warn you. Okay, in case of that. Okay, so when it equals to, yes, that's definitely when we need to exit, but it's too late already. Because if you think about it, okay, after I increments, it becomes n. So that means before it increments, it is n minus 1. But then it also means we are comparing a bracket n minus 1 with a bracket n. A bracket n is not an element in the array. What is the index of the last element of this array? The array A has n elements in it. What is the index of the last element of array A? Okay, I'll simplify this. I'll give you three choices. Is it n minus 2, n minus 1, or n? Which one is the which one is the index of the last element of this particular array? Nope. Okay, we got two more choices. Nope. It's n minus 1. It is n minus 1. Okay, so that means if I equals to n at this point, then before this statement, I is n minus 1. But when I is n minus 1, this is not a problem because I is still n minus 1, which is the index of the last element already. But if I itself is n minus 1, then I plus 1 is what? Is n. And n is not a valid index in this particular array. So that means this is a little bit too late. What do we need to do to make it exit just a little bit earlier? You have two ways to fix this. You can either fix the expression on the left-hand side, or you can fix the expression on the right-hand side. We just need to exit one number or one value earlier. So how would you specify that? You can do a plus 1 on this side. You can also do a minus 1 on this side. Is that okay? All right. So, okay, so this is when we exit the loop. Okay, that's good. All right, so we'll call this version 1, and now we work on version 2, which is going to be the C code that we want. Okay, so we are reworking everything here so that we can get the actual C code. Okay, so I'm just going to copy and paste and then do some modifications here. So copy, paste, there we go. All right. So the first thing we need to work with is, oh, if there's nothing for else to do, we just get rid of the else. And there's no end if in C, so we get rid of the end if. Okay, so that part is rather easy. Okay, so now this actually look like proper C code. So now the question is loop and loop. Okay, there's no such thing as loop and loop in C and C++. We got two types of loops. Can someone tell me which two types of loops do we have? No, 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 we are not doing for loop. A for loop is a special version of a while loop. So what loops do we have? A do versus a while, right? A do loop is a post-checking loop, and a while loop is a pre-checking loop. Okay. So in this case, it is somewhat of a philosophical question because the question is, will you ever be given an array that does not have enough elements to even perform one single iteration? To perform one single iteration, it means you need to have at least two elements in the array. So can you be given an array that only has one element, which means yes, okay, it has one run for sure, we're done. No need to ask another question. So that's kind of a philosophical question. And it is one of the questions that you need to ask your professor. Okay, if this is your homework assignment in CISP 360, then you need to think about this and go like, okay, I need to ask my professor, what is the smallest array that you will give me to process with this program? Does that make sense? Does everybody understand why you need to ask that question? If you need to determine whether to use a do loop versus a while loop, which one is safer? If your professor goes like, well, just write your code in the safest possible way, which loop would you use instead? A while loop. Yep, because you always check the condition first. So that's what we're going to do. Okay, we're going to turn this into a while loop. So I'm going to do this. Okay, so we'll specify a while condition here. And it looks like we got two statements to perform in the loop body. Why do we have two statements? Because this is one statement. This is another statement. Both of these need to be done in the body of the loop. Does that make sense? Okay, so we got two statements to do for each iteration. And then you go back to the BNF and you say, oh, but tech, we have a problem because a while loop can only have one statement as the body. How do we fix that problem? Hmm? No, no, no. Okay, I got two statements that are sequential to each other that I need to do for each iteration of the loop. But the syntax of a loop says you can only have one single statement. Yes, a block statement. Very good. Okay, so every time you need to quote unquote, zip up multiple statements into one single statement, that's the job of a block statement. Okay, so that means braces. Okay, very good. Okay, so we'll just specify braces here. Starts from here and it ends right here. Very cool. Okay, so we'll just kind of comment out this part here. Okay, because that is not proper C syntax, and neither is this. Okay, we got one more thing to do. This condition here is the exit condition, which means we get out of the loop when I is equal to n minus 1. But whatever condition we need to specify here is a stay in loop condition. Okay, this is when we stay in the loop. So what is the relationship between the condition at which point we exit the loop versus the condition that specifies when we need to perform another iteration? How are they related? We know they're related, right? Yes. I does not equal to n minus 1. That is correct. One is the logical negation of the other. Does that make sense? Just imagine this. You're trying to tell a worker, okay, you say you're not you're not going to move on to the next task until the dishes are done. So that means until the dishes are done, that is a the dishes are done is an exit condition, which also means if you want to specify as long as the dishes are not done, do not proceed with the next task. Does that make sense? So that means, oh, okay, so that means with this loop here, we just take whatever this is, okay, copy and paste, okay, we paste it here, but we have to remember to negate it, which is the same thing as what you mentioned earlier, not equal to. But if I want to be as lazy as possible, this is what I would do. What does exclamation point mean in C++? Logical not. Okay, yes, that is correct. So you guys might say, isn't not already logical? Why do you have to mention logical not? Because later on in CISP 360 and CISP 310, you will encounter another not. It is called a bitwise not. So every not that you're going to use in this class, also in 360, is most likely going to be a logical not. Okay, but later on, there's another not. It is called a bitwise not. So when I specify things, I just try to be as clear as possible. So I would say logical not in this case, which is really just not. All right, so I think we are done here, but I'm going to improve the code just a little bit. I'm going to improve this a little bit by getting rid of this logical not here, okay, which means the extra parentheses are not needed anymore. But I'm going to specify, instead of not equal to, I'm going to specify less than. Because not equal to means it can be less than or greater than. Less than is the one that we need in order to stay in the loop. Okay, just in case something goes wrong, this is the best way to specify the condition to stay in the loop. So are we good at this point with this code? Okay. So when you think you're done with the logic here, then it's time to test it. Okay, so we're going to test this code with a trace, which I think we have enough time to do, but we may not have enough time for, well, I think we do. So we'll go ahead and keep this around and specify the loop. Okay, so this is going to be line 1, line 2, line 3, line 4. Yeah, I know it's uglier than usual, but it's still gonna work. Line 5, and this is line 6. Oh, 6, 7. There we go. And then we're gonna take a screenshot of this so that I can display that all the time, like so. And then move on to a new spreadsheet. Okay, new Google Sheets. Yes, go ahead. Name it after today's date. 2005 0324, and this is going to be the trace. So we got line number, we have um, variable I, we have variable n, which is not going to change in any way. We have number of runs, okay, run counter, and then we have array A. So array A, do we want it to be this long? That's kind of long. We can reduce it a little bit so we can have, let's say, 5 elements only. Okay, 1, 2, 3, 4, 5, and we're gonna have 4, 5, 3, 4, and then 1 again. Okay. All right. So let me shrink the columns a little bit. And have our comments over here. There we go. And this our precondition. N needs a value to begin with because it's the number of elements. It is going to be 5. And then let me go back and show the code. I can get rid of this now. Always on top. All right, so I'm going to do a kind of quick run here. On line 1, I gets initialized to 0. On line 2, oh, okay, I take it back. It is run counter that gets initialized on line 1, and then line 2 initializes I to 0. Oh, that's also initialized to a 1, not a 0. On line 3, we have the condition, so we have to specify I, which is a 0 at this point, is less than n minus 1, which is 4, is true. Okay. Then we move on to line 4. Line 4 says, yeah, what is the result of a bracket I greater than a bracket I plus 1? I is 0, so a bracket I is a bracket 0, which has a value of 4. I plus 1 is 5. Okay, can you guys kind of mute the phones, please? Thank you. So I plus 1 is 1, so a bracket 1 has a value of 5. 4 is greater than 5 is false. Okay, so we specify this is false, which means if there's a else, we go to the else, but we don't have an else, so we move on to line 6 in this case, which is just adding 1 to I. I goes from 0 to 1. Then we go back to the beginning of the while loop on line 3. I is less than n minus 1 is still true because I is 1. 1 is less than 4 is true. Then we go back to line 4. A bracket I is a bracket 1, which is a 5, greater than a bracket I plus 1, because I is 1. 1 plus 1 is 2. A bracket 2 has a value of 3. 5 is greater than 3 is true. So now this time we have to go to line 5. So on line 5, we increment run counter by 1. It is now 2. Then we proceed to line 6, which increments I to from 1 to 2. Then we go back to line 3, which then asks, is 2 less than 4? Yes, it is true. And we go to line 4. A bracket I refers to a bracket 2, which has a value of 3. A bracket I plus 1 refers to a bracket 3, which has a value of 4. So 3 is greater than 4 is false. We then skip line 5. We get to line 6. We increment I from 2 to 3. And then we move on to line 3 again. I is now 3. 3 is less than 4 is still true. So we get to line 4 again. This is when I need to split the screen a little bit so we can see. We can basically scroll one part without scrolling the other part. All right, so line 4 evaluates a bracket I. I is 3, so we are comparing 4 to a bracket I plus 1. And I is 3, I plus 1 is 4, so a bracket 4 has a value of 1. So we are comparing the 4 to the 1, so that is true. So we now go to 5, which is the then statement of the conditional statement. We add 1 to run counter, which is incrementing from 2 to 3. And then we get back to line 6, which increments I from 3 to 4. We go back to line 3. I is I, which is now 4. N is 5, but N minus 1 is 4. 4 is less than 4 is false. So now we are done, just in time. So are we doing okay so far with this trace? But more importantly, are you guys starting to understand the process of putting an algorithm together? Some people can just sit down and just start to type out code. Some people cannot. Okay, this is a good way to start. There was a question. Yeah. hmm So n always has to be given because you need to know the number of elements in the array. Yep. So n and also the values of the array, they must be given in order for you to trace anything. Yep. Let me stop the recorder first.